Dear students, welcome back to our second lecture on research methods. In this chapter, we want to do a deep dive on one of the central topics of research, namely how to acquire data that makes sense and can be used in a meaningful way for the remainder of the scientific process. Core issue here is the notion of metrics. We try to identify numbers that make sense to characterize our scientific object of study, make them measurable, and make them meaningful, interpretable. Whenever we observe real outcomes, there is a need to precisely define what is it we want to observe. How do we actually determine the outcome? What is the exact procedure that needs to be followed to arrive at the final results? How to measure, how to quantify it, if it is quantifiable, or how to qualitatively describe it if it's only qualitative data. This is actually less trivial than one would expect, but it's fundamental to good research. Two people that observe the same incident may come to wildly different conclusions if they measure the observation in different terms, if they quantify things somewhat differently. And this is absolutely not trivial. Let's take something as simple as code. How do you count? How do you measure the size of code? Do you count empty lines? Well, maybe not, because they are not really contributing anything to the essence of the code. What about multiple statements on a single line, as is allowed by most programming languages? Are they a measure of size? Should I count then multiple statements on a single line as 2 lines, quote unquote? What about comments? Some people write a lot of comments, others very few. Is the code equivalent with many comments to the one with few comments? But on the other hand, writing comments is not the same as code. So should we measure comment lines just as regular code lines? Or should we say 2 comment lines equal 1 code line or something like that? There are many different ways how you can even measure something as trivial as the size of a block of code. And actually, quite a few of them are actually used. So, whether to count empty lines or not, both variations exist. Multiple statements on a single line, both variations exist. With or without comments, both exist. And actually, it is hard to say any of these doesn't make sense. I mean, if I want to understand code in the sense of what the machine is actually executing, what is the code complexity that is described, now the size of the commands to the machine, then I should ignore empty lines, I should ignore comments because they are not contributing to that. If I try to qualify what a developer did, I may want to ignore empty lines, but definitely there was some investment in the comments. Also, the number of comment lines may have an impact on the understandability and possibility to make changes to this code. Thus, it really makes sense that there are multiple lines of code in matrix, because they are useful for different circumstances. So let's do some short definitions. First of all, what is a measurement? A measurement is a mapping from a property of a process, product, activity, or resource to the formal world. Meaning, we take something in the real world and derive an abstraction from it. Basically, our theory world in this terminology that we introduced in the last lecture. The measurement is a mapping, meaning I do the observation and I get a result that makes sense in the formal or in the theory world. A measure is a number or symbol assigned to an entity by this mapping in order to characterize it. Meaning the measure is the specific value in our formal or theoretical world. A metric is the entity that is measured. Let's have some examples. So for example, a metric could be something like lines of code metric, the number of test cases, the effort that is required to develop the test cases, etc. These are real-world objects that are quantified in some way. The measure, that would be here exactly the number of lines of code, for example, is a natural number, respectively is a specific number for a specific piece of code. So the measure is a number and that number is part of the theory. The measurement is how to produce a number from the code, meaning this is our mapping procedure, and that can be very difficult. Here it's pretty simple, at least as long as we precisely define what we mean. So for example, the measurement procedure could be take the original code, forget about all empty lines, forget about all the comment lines. If there is more than a single statement on a single line, then this one counts as multiple lines, and all declaration lines and other lines filled with pieces of code count. Now produce the number of all of these entities. That's roughly how a measurement procedure would look like. Ideally, it would be precisely described in a measurement description, and in cases like lines of code, we can even automate it, meaning we can write a program that does the observation for us and produces the number. In that case, it's highly reproducible. That's a pretty nice property for a metric. However, it's not easy, not always as easy as this. No? Especially if we have to deal with people, like let's say the effort required to develop the test cases, that's nothing we can easily observe in a fully automatic way, because that's something about the people interacting during system development. So it's outside of the scope of what is easily observable. In those cases, we need other measurement procedures that need to resort either to other tools, like for example, ask the developers through questionnaires, or we need to make approximations, like we approximate effort by certain interaction times with the code, respectively with the test cases. There are different categories of metrics. There are objective versus subjective metrics. An objective metric is a determination of value independent of a person. That means if I have a precise procedure for performing the measurement and two different people do it, they will arrive at the exact same value. Now, that's when we call it objective. That's definitely a desirable property of a measurement. Unfortunately, it's not always easy to achieve. So there are also subjective determination of value In that case, the final value depends on the person, meaning if I give the same task, the same measurement to two different people, they will arrive at two different, or they may arrive at two different results. Why does that still make sense? And why can it happen? Let's again take a very simplistic example. We look at some code and we look at the complexity of the code. Is a piece of code very complex or not? You may already have had cases where you did some software development together with partners, and while you found it easy, they found it difficult, or vice versa, working on the same piece of code. In that case, the evaluation of such a metric would differ for you. And it may make sense because it may be influenced by how used you are to the specific system, how used you are to the programming language, how experienced you are in software development as a whole, and so on. So it may make sense that you arrive at two different values because actually the values in this case not only say something about the object, meaning the code and its complexity, but also about the observer. Further, there are also direct versus indirect metrics. Direct metrics are metrics that can be directly determined based on a measurement. These are results that we can get directly as a mapping from reality to the theory domain. Indirect is something, or is a metric, if it is derived from direct metrics. For example, the productivity is usually not measured directly. Rather, we measure the size of a problem that is solved and the effort someone needed for solving this problem. And then the productivity is size divided by effort. For example, productivity in software development is often measured as number of lines of code divided by effort to achieve that. I don't want to start an argument right now whether that is a meaningful way of defining developer productivity. I'm just stating the fact that that's what you often may see. Further, metrics may be subdivided into product metric, process metrics, even people metrics, things like that. All of them are relevant for characterizing a situation as a basis for research. And not only as a basis for research, it's actually for any case where you do some sort of improvement.